Okay, for what we have in the section R.6 simulation, we have among complex numbers, we have, first of all, writing in terms of I, it says to simplify the square root of negative 52 as much as possible. And for what we have here, with the square root of negative 52, again, we're going to have a complex number. And you can separate, so we have the square root of 52 times the square root of negative 1. And the square root of negative 1, okay, that becomes I. Now, so far we have the square root of 52 times I. Now, 52 is not a perfect square number. However, 52 is a multiple of a perfect square that is greater than 1. And the highest number that is a perfect square and is divisible into 52 is going to be 4. And so we have 4 will go into 52 13 times. And looking at what we have thus far, so we have the square root of 14, make that the square root of 4, times the square root of 13 times I. The square root of 4 becomes 2. Then we have times the square root of 13 times I, and you can also write that as 2I times the square root of 13. And going back and checking the results. And it is correct. For what we have in the case of the next item, we're looking at finding all complex solutions of 2x squared plus x plus 6 is equal to 0. And in this equation, if we look, okay, so we have a quadratic equation that is in standard form, and we cannot factor this trinomial on the left-hand side of the equation in terms of integer coefficients. So we will once again utilize the quadratic formula. So we had that a is equal to 2. And from positive x, I have that b is equal to 1. And we have that c is equal to 6. And setting up what we have for x, we have negative b, which is negative 1, plus or minus. And we have the square root. So you have b squared is 1 squared. And we have minus 4ac. So I have minus 4 times 2 times 6 all over 2a, which will be 2 times 2. Again, inside the radical, so I have 1 squared is 1. Negative 4 times 2 is negative 8. Negative 8 times 6 is negative 48. So this will become negative 47. So we have, in the ratio, we have negative 1 plus or minus the square root of negative 47 all over 4. And for what we have for the square root of negative 47, we had the square root of 47 times negative 1, and that would become the square root of 47i, or I times the square root of 47. And 47 is a prime number, and the highest perfect square that is divisible into 47 is only going to be at 1. So we're going to have negative 1 plus or minus. And you can say I times the square root of 47, or the square root of 47 times I, and do not have I inside the radical. And we have all over 4. And checking the results, and I do have to separate these solutions. So for what we have here, we have negative 1 plus the square root of 47. And you have I all over 4. And we have negative 1 minus the square root of 47i. And you can put the I in front of the square root of 47. And we have all over 4. and checking the result, and it is correct. Now, for the third problem, it says to find all complex solutions of 2x squared minus 3x plus 5 is equal to 0. And looking at what we have. So we have for this equation, for 2x squared minus 3x plus 5 is equal to 0, we have a quadratic equation that is in standard form. And this one is also not factorable in terms of integer coefficients. Now, 2 times 5 is 10, and there are no integer factors that will amount to -3 in terms of adding and subtracting. You have like -2, -5, +2, +5, 1, 10, or -1, -10, and none of those combinations will add up to -3. So again, reapplying what we have for the quadratic formula, the coefficients a, b, and c will be respectively 2, -3, and 5. And setting it up in accordance with the quadratic formula. So we have -b is going to be the opposite sign of -3. And we have plus or minus the square root. And we have the square of -3 minus 4 AC. So we have minus 4 times 2 times 5. And you have all over 2a, which will be 2 times 2. Again, -3 squared is 9. -4 times 2 times 5 is going to become -40. So we have -31 in the difference. So you have 3 plus or minus. Okay, you have the square root of -31. And by then, you can write this in terms of I. So I had the square root of -31. So this will be the square root of 31 times I, or I times the square root of 31. So we have in compact form, we have 3 plus or minus. What's going to be the square root of 31 times I all over 4. And if we look at itemizing, so testing out what we have here. So we have 3 plus the square root of 31i all over 4. And we have, again, 3 minus the square root of 31i also over 4. And checking the result. And that is also correct. Now for the next item. Okay, so we have an application problem. This states a model rocket is launched with an initial upward velocity of 175 feet per second. The rocket's height h in feet after t seconds is given by the following equation, whereupon we have that h is equal to 175t minus 16t squared, and it says to find all values of t for which the rocket's height is going to be 85 feet. Okay, and it says to round your answers to the nearest hundredth, or in this case to the nearest 2 decimal places. Okay, so we have for the formula, we have h is equal to 175t minus 16t squared, and we're looking at the times upon which the height is going to be at 85 feet. So we have 85 is equal to 175t minus 16t squared. And what you can do is that you can move the 85 over, and we'll just sort of shuffle things around here. So we have that 0 is equal to negative 16t squared plus 175t minus 85. And let's say that if we were to just change the signs here. So if I multiply or divide by -1, or you could also just kind of rewrite this where negative becomes positive and vice versa. So we'll say we have 16t squared minus 175t plus 85 is equal to 0. And here, if we apply the quadratic formula, so we have that a is equal to 16, and we have that b is equal to negative 175, and we have that c is equal to 85. And looking at solving for t, not x, but we're still going upon the same premises with a, b, and c. So we have negative b is going to be the opposite sign of negative 175. And we have plus or minus the square root. And we have a b squared minus 4ac. So we have minus 175 squared minus 4 times 16 times 85. And we have all over 2a, which we have at 2 times 16. And after we fill in the values, okay, so we have positive 175 plus or minus. Okay, so we have for the square of negative 175, and we have minus 4 times 16 times 85. And we have for the difference, okay, so we have what's going to be the square root of 25, 185. And in this one, say a plus or minus the square root of 25, 185. And we have all over 32. Now we're not looking at reducing the radical. So we have just on the plus and minus side, so we have for 175 plus the square root of 25, 185, all over 32. Let's say that just from this particular vantage point. So you have 175 plus the square root of 25, 185, taking that sum and dividing by 32. And so we have about 10.43 seconds. So that will be the higher value. And in the case of what we have at the other extreme, where we have 175 minus the square root of 25, 185, all over 32. And so we have in this particular instance, say 175 minus the square root of 25, 185, and we have divided by 32. And so we're looking at the nearest two decimal places right at 0.51. Okay. So for what we have in this case, right, so you have 0.51 or 10.43, and checking what we have here, and the result is correct. Now for the next item, okay, so you have something that looks almost like square root property of equality setup, but it's not quite that in the purest sense, because you have the square of a binomial not set equal to a constant. Instead, you just have it set equal to a trinomial. And we have the square of y minus 2 is equal to 2y squared plus 3y plus 14. And taking what we have here. Okay, so we have for this equation for y minus 2 squared. Again, this means that we have, in terms of multiplying, we have y minus 2 times itself. And again, we have equal to 2y squared plus 3y plus 14. And for y minus 2 times itself, if I FOIL out, and we have y to the second, negative 2y will combine to negative 4y. And we have plus 4 is equal to 2y squared plus 3y plus 14. And here we have a quadratic equation, again, not yet set up in standard form. And so we have y squared terms on the left and right. And we'll just take out the terms on the side that has the lower y squared term, and that's going to be deducting everything positive from the left and adding the negatives also from the left. So you have minus y squared, and we can undo the presence of negative 4y by adding 4y. And we can take away 4. So we have for the whole left-hand side, Okay, so we will have that 0 is equal to y squared. And we have 3y and 4y will make 7y. 14 minus 4 becomes 10. And so in taking what we have now upon factoring, so we're going to have the quantity of y plus 5 times that of y plus 2. And so we have, upon setting what we have here equal to 0. So we have for y plus 5 is equal to 0 and y plus 2 is equal to 0. Okay, we will have with our two solutions, we will have that y is equal to negative 5 and that y is equal to negative 2. And checking the results. Yeah, so we have negative 5 and negative 2. And checking. And that is correct. Now, for what we have in the case of the remaining portion in the simulation, we're looking at a higher order equation, and this is going to be an equation that is not quadratic, but quadratic in form. And here we have x to the fourth minus 37x squared is equal to negative 36. Okay, so we have, for this equation, we have x to the fourth minus 37x squared is equal to negative 36. And if I put this equation that is quadratic in form also in standard form, and that is to set equal to 0. So I'm going to add 36 to both sides. And so we're going to have x to the fourth minus 37x squared plus 36 is equal to 0. And for x to the fourth, okay, that times itself, that will give you x to the fourth is not x, but instead x to the second. And for the factors of 36, that will add to negative 37. We'll have a negative 36 and a negative 1. And we have, with these differences of squares, we can factor further, or we can just go ahead and set these equal to 0 and apply the square root property of equality. So you have your choice of methods. And if I set x squared minus 36 equal to 0 and adding 36 to both sides, we have that x squared is equal to 36. And we have, with the square root property of equality, we have the x will be plus or minus the square root of 36. And in case of what we have here, we have the x equal to plus or minus 6. As for x squared minus 1 equal to 0, if I add 1 to both ends, okay, so we will have the x squared is equal to 1. And we have the x equal to plus or minus, okay, the square root of 1. And so we have the x is equal to plus or minus 1. So again, writing in expanded form, so we have x equal to 6, negative 6, negative 1, and positive 1. And just taking what we have now. Okay, so testing out the results here. So I have negative 6 and 6, 1, and negative 1. And checking out the results, and it is also correct.